Okay, so in this short exercise, we'll just take a look at the basic building blocks of any grasshopper file. So points, planes, and vectors. So to start off, we'll just kind of demonstrate the relationship between the three. And we'll go over to the vector tab up top here, and we'll grab the construct point component. And you can see that it will draw a point in space along any x, y, and z position. So we could grab a parameter here and go over to slider, grab a slider. We'll edit that slider by right-clicking on it, changing it out to integers for now, and increasing that value, the maximum value up to 10 in this case. And just copy and paste those. Oops. And then go ahead and plug them in. Now you can see as I change these inputs, I draw a point on screen at those coordinates. A vector is going to work in a very similar way. So let's go to vector, and in the vector box on the right you can find x, y, z, vector x, y, z. You can go ahead and copy and paste these three because we can just reuse those. And now if we plug these in, nothing will appear on screen. That's because vectors aren't by default previewed as their mathematical constructs, but you can visualize them. So let's go to display and click this little vector display tab here and bring out that component. And it's going to ask you for an anchor point, so a place from which the vector will be drawn, and then it will show you that arrow. It'll show you the vector as an arrow. Right? So we know that this is our vector, and we can go ahead and use the point that we have on screen, for example. Now, you can see what's happening here. I'm drawing an arrow, and there's a direction to that. And that direction is actually set from the origin point to the point that I set using these three sliders. And that's going to set the direction. The anchor point is just there to draw the vector. The vector can be drawn anywhere, but it will always be in the direction that is set between origin and the xy inputs and z inputs that you give it. So I can draw this angle, let's say something like this, from this particular point in space back to the vector, back to the origin of the vector, and then if I move its anchor back and forth, you can see that the direction doesn't change, but its position does. Okay. Now the last thing, so if this is a location and if this is a direction, one of the last things to consider is the orientation. So we can go back to the vector tab here, and we can go to plane, and I'll use the plane normal to illustrate this. So we grab the plane normal component. This is going to look for a location input, so I can, an origin point, so I can set that as the point that we currently have on screen or anything else. And by default, we should be seeing a plane here, but it's a little bit small. So what I'm going to do is I'm going to go to display tab up top, the menu I should say, and change my plane size from default to 0.2 to something like 4. So I can see it on screen there. As you can see, now it shows up quite clearly. And then the z-axis of the direction here, we're just going to draw that out of the vector that we've drawn with that previous component there. And now we can see that if we go to perspective view in 3D, that we've gone ahead and made a plane perpendicular to the vector, which has a starting point a shared starting point between the two things. All right, so again, if I move that around, nothing will change in terms of the angle, just the position. If I move this point in space, I will reset the vector at a different angle, and I will then change the orientation of the plane. Okay, so just a little bit about the relationship between the three things. This is used in every grasshopper file, and it's very, very useful, especially when we start extracting this sort of information from other objects, especially in 3D. And we can get to that in the next few tutorials. I'll just quickly pause here so you guys can just take a moment to pause if you have to, and go ahead and develop this little sample. Okay, so let's try to make some use of this. What I'll do is I'll just turn all this stuff off, so I'll grab it, and I will use the little mouse, the scroll wheel in the middle as a button, and turn everything off. And I'll just move it. You can start a new file as well if you like, but I'll just go ahead and move it and start from scratch over here. Okay, so we're going to start in a similar way, but we're going to use instead multiple objects. Instead of just one point, we'll start with many points. Okay, so we'll use a grid for that. So let's go over to the Vector tab again, and in the grid area, we can find a number of them. I'll just choose rectangular for now. Okay, and this is going to output by default a series of polylines that you can see as a grid, and the points at the corners, which are not by default previewed. But you can also see that there's a plane down there. So let's turn that off. Let's leave it alone. And then let's take a look at the inputs. We've got a sizing and we've got an extents. So this is going to control the density of the grid, the spacing of the grid, and the extents. So I'll go back to parameters and grab another slider, and I'm just going to set this to 1. Okay, and then the other thing that you can do while you're here is grab a curve component, a curve parameter here and a point parameter. And what that's going to do is allow you to kind of pick and choose what you preview on screen. And then the last thing is to grab another slider. We'll right click on that. We will edit it again. Maybe we'll make it integers, and we'll change our max out to something like 50 and the minimum to 1. Okay, you can double click in there and hit the green button when you're finished so that it sets it. And now I can set my overall size of the grid. So what I'll do is I'll just make that 30. Okay. So I got a nice big grid here, a bunch of points. The next thing I want to do is take a look at the organization of it. And this is something I'll double back on in later tutorials, but for now what we want to do is just go ahead and flatten this. We don't need the points here to be organized along columns or rows. We want this to just be basically acting like a single field of points as opposed to multiple lines of points. And we'll get back to that again with later exercises. Something else that we covered a little bit last semester, although we didn't really get into detail about it. Okay. The next thing I want to do, just to quickly demonstrate the drawing of geometry along each one of these points. So this is we're just going to kind of set our geometry that we'll deal with. For now, we'll deal with circles. So I'll go to curve, primitive, and circle. Okay, and I can set all my center points, and then I'll set a common radius, and I'll just grab a slider for that, just so I can, get it rolling here, just to get a little start. And then I'll turn off the preview of those center points because they're just getting in the way. Okay, but this is of course not where we want to be. We want to show some relationship between a series of points, direction, and the planes that come from those directions. So let's keep going. The next thing I'm going to do too is I'm going to set a simple parametric relationship that allows me to control all of this. So I'm going to draw a few points in Rhino. Right, so I'm just going to go over here, select my point tool, and just draw a couple points on screen like that. I'll go back to Grasshopper and grab a parameter again of points. Right click on that little box there, and when you see set multiple, click that. Grasshopper will disappear, allowing you to click your points, and hitting enter will set them into Grasshopper. To set them in permanently and to give you a gumball over each one of the points through GH, you could right click on that component and you can click internalize data. So that'll internalize and save the location of those points and allow you to update it even after these have been deleted. Which means if you don't save your Rhino file, that in this case it's okay, you won't lose your points. So internalizing simple geometries like this is quite helpful, especially if they're input geometry, because then later on, if you forget to save your Rhino file, you won't be left out. Now what we're going to do is measure the distances from this set of points, which we're going to call attractor points. And you can read up on this a little bit in the primer that we set up in Miro. And we're just going to build on that example in this case. But we're going to measure, anyway, we're going to measure the distance from these points to all the other centers on the grid. Okay, so let's go back to vector. We'll go to point, and we'll find the pull point component here. The geometry we're going to pull to are those points, and the set that we'll search from will be the center points. You can turn off the preview of this. We don't need to see that because really what we're interested in is the distances, the numbers. And we know if we take a look and we just hover over, you can see that they're quite, they're going to be larger than the spacing of the grid, of course, right? Because we're We're measuring the distance from some sparse points that aren't related to the grid back to the grid. And we know that if we use these as radii, they're going to be very, very large. So before we even get there, why don't we just go to math? Let's divide these numbers to kind of control them a little bit, to give us some more control. And for that, we can just maybe borrow this slider over here, just copy and paste that over. Now the numbers are a bit smaller, something we can probably deal with if we add it to our radii input. Okay. So now, as I move these points around screen, you can see that there's an updating that's occurring in terms of the sizing of the circles. And the reason is that the values that are coming out of the measuring of the distances between the attractor points in the grid are being used directly to affect the size of the circle. So the closer the point is to the circle, the smaller that circle will be because that value is smaller, right? Now the other thing that you can see, you're getting some overlap here, regardless of whether or not we're dividing this. So you divide it a little less, and of course the overlap will be more. Divide it more, and the overlap will be less. But this is not this manual way of working is maybe not the best way of working, because you always have to then change two parameters in order to get the pattern to emerge properly. So why don't we set a little bit better of a tolerance there. So let's do something like this. And then what I'll do is I want to pay attention to this value here, because this sets the distance between the points. And then while we're in this math tab up top, I'm going to go over to utility on the right. I'm going to find this minimum component here. And then what I'm going to do is divide this number by 2, because again, we're dealing with radii or radiuses from the center out. If there were diameters, we wouldn't have to divide. So it depends on how you're setting the circle. But because we're using radii, and it's because, so basically the max size for that radius is 1/2 the distance between these 2 points and those 2 points, right? So it's 1/2 the distance. So we can divide that by 2. Okay, so I just grabbed a panel there. Under parameters, this yellow button here is a panel. Yours are going to look a little different on your screen. They're going to look yellow. I changed the colors. Okay, and I'm going to divide that. So now every time I update this value here, the rest will change. It won't break the file downstream. So that's nice. And what we want to do then is compare this number. Oops, sorry. I made a little mistake there. Let's just divide this. What I meant to do was divide this by 2. So go to math, grab another divisor here, and divide this number 1 here by 2. And that'll be the A input into the minimum component, like that. And then this other division here coming out of the distances is going to go into the other input of the minimum component there, right? Because we're going to be testing against basically the smallest of, or sorry, the largest of values that we're going to want this thing to be is 1/2 the spacing. So this is going to return the smallest of 2 numbers to make sure that we never exceed that. So we can swap out those radii values for that new little bit of control. And now as I move this thing around, the circles, regardless of how far I am away from them, won't overlap. You can see they'll just touch. If I increase this just by a little bit, I can get a little bit more space in between those circles like that. And maybe even more if I'm doing something like laser cutting. I want to have a little bit of material left over, right, if I want to try to develop some kind of perforated panel or something. And we don't want those to touch. Right? So now no matter what I do, I can't really break it. Even if I change the size of the grid and change these original inputs, it won't affect. Right? It won't have any adverse effect on the result. Okay. All right. So let's kind of add a little bit more to this. So we can see here that we've got 3 points making changes. But you can also use, what I like about this component, and this is why I like to use it, is that it allows for different kinds of input geometry into the geometry that actually affects the distances. And one thing we can do then real quick is to just play around a bit with curves as well. So let's draw a curve in Rhino. And it doesn't matter what it looks like, something like that maybe. And then I'll go to parameters and Grasshopper. I'll put that into a curve parameter, just like we did with the points, and we can just swap those out. Okay, and now if I move the control points around, I get some more action out of this. I can make changes to the curve itself in order to affect the pattern. You can also do both. If I hold shift and add both as inputs, you can see now that the points and the curves are simultaneously affecting the result. This value will change the kind of fall off rate, if you will. So you can fine tune this thing. Okay. So a little bit about, a basic parametric relationship between different things on screen. So in this case, point to point, and in this case, curve to point, which in the end really just breaks down to point to point, but it's useful to think about it instead as having a curve as an input. Okay, let me zoom out just for a second here, give you the overall picture. I guess I'll move that, just delete it. This way you can give it a quick pause if you need to and sort of catch up. Okay, what I'm going to do next is I'm going to just disconnect the curve. That's a little something to practice. And I'm going to hide the curve in Rhino. I want to get back to just having a kind of simple a simple setup here, so that the next step we can break down and explain. We're going to start then to incorporate vectors into this in order to rotate these circles relative also to the distance that the points are away from them. All right, delete that. Okay, so let's go over to vector, and we'll go to this vector tab on the side here, and we'll go to vector 2-point. It's going to look like this. We're going to draw a vector from these points to those points. And then we're going to use this vector to set the angle and the orientation of a circle. Now, we could do something similar like we did in the last example. Or we can also use a different component, which gives us that input. So we can go to curve, primitive, and circle CNR. Right? This is going to give us the option to set a normal, which is a perpendicular vector. The center points will be the same, and the radii will be the same as we've been using, like this. Now, if we look at this in the top view, you see a bunch of lines, but in actuality, those are circles that have been rotated to be perpendicular exactly to the vector between the attractor points and each one of the circle's centers. So let's go to 3D here. We'll just move this around. Yeah, you can see now that there's a bunch of circles. We can turn off these so we don't get confused. Move that up there maybe. And now you can see that the circles are not being rotated in 3D relative to that vector direction. What's interesting here is that we can move these things around in the z-axis as well, and we'll get a nice effect out of that in the top view. Let's go over here. All right, so as they get closer, they'll rotate less, meaning that they'll look more like lines in the top view. And as we get further away, they're not only going to get bigger, but they'll rotate more to face the top view, because they're literally facing the point that we're moving around. It's almost like following it, Okay. And we can do something similar with the curve as well. It doesn't change this functionality. In fact, you can even show that curve again, and you can even put these control points in and manipulate them in 3D as well. And you can get different effects out of that. Okay. But for the sake of simplicity, we'll keep it at this for now. Just knowing, of course, that you can, by inputting more kind of pulling geometry or controlling geometry, you do end up with either more complex or more controlled patterns, depending on how you set it up. Okay. I did want to just quickly show that we can use the same components that we used before to draw the circle too. So we can go back to vector, plane, and the plane normal. That's basically what this thing is doing anyway. So we can set those planes at each one of those points to draw them out for each circle. Then we can turn this off because we don't necessarily need to see the preview there. And the vector that's going to set, those directions is coming right out of here and into z. And then we can go ahead and plug it into our old component there, and you shouldn't notice any difference. It should be exactly the same. Okay, so it's just a little bit of a basically the same result, just different components. But again, just kind of illustrating the relationship between directions in space, the planes upon which geometry is drawn, and the points that are shared between the two. So this will be the base for your assignment. You can read up on UB Learns on that. But there's a lot of room for exploration here. First of all, of course, in the attracting geometry, whether or not it's curves, points, what have you, or I should say these two things, but a different combination of them. So more or less points, close apart or further apart, whatever. The shape of the curve and whether or not you have more than one of those. You can experiment there. Of course, the grid here can also be changed into, let's say, a hexagonal grid, like you'll see in the example in the primer. There's also spacing, there's density shifts. There's also the geometry we're drawing. Here we're drawing circles. One can draw different geometries as well. And that will, each one of them would have their own sort of inputs in order to do that. So, for example, the rectangle here, in order to center it, you have to do one more thing, which is to basically give it a domain to set its dimensions, which is different than just a simple number for a radius. So pay attention to that and see if you can maybe figure out how you might draw squares instead of circles. And that's a good, that's something we can follow up on in class if there's any questions about that. But in any case, take a look at the examples. Take a look at how we're making some connection to some architectural examples as well, and use this as a base from which you can start a drawing in the 2D view of your developed pattern.